Okay, so we've talked about the birthday problem now, and we've talked about this fact that as you increase the size of the group, the probability that at least two people have the same birthday gets pretty high pretty quick. And by the time you have 23 people, which is a pretty small group, it's more than 50%. 23 is the number where it crosses the threshold there. And as I've said, people are usually surprised by that. Uh, one reason why they're surprised is that it's very easy to conflate the birthday problem we're talking about with a different one. Okay, we're talking about the probability that in the group there's some pair of people that have the same birthday. That's not the same thing as picking one person in the group and saying what's the probability that somebody has the same probability, the same birthday as them. Okay. And this conflation uh, happened on late night television in 1980 on The Tonight Show, way back in the day when Johnny Carson was the host and his sidekick that he chit chatted with in between guests was Ed McMahon. And they talked about this. And in the written notes for this, I have a link to the video of them discussing the birthday problem, which is hilarious in a number of ways. But one way in which it is kind of funny is you see them like start with the right idea and talk themselves into the wrong idea. Um, so Johnny starts the conversation and he tells Ed that he's read this thing that says, yeah, with a um, group of 20 or so people, the probability of having a shared birthday gets pretty large. Um, and Ed's like, no, that doesn't really make sense to me. The group would have to be much, much bigger. And Johnny says, no, I read it. It's got to be true. And it says, well, look, we've got a group of about 50 people here. Show me. And, or maybe Johnny volunteers. I'm not remembering exactly how the exchange goes, but Johnny picks somebody in the front row and asks the lady what her birthday is. And she says, she tells him her birthday, it's like August 9th or something. And he says, okay, so who else has got that birthday? Crickets. Nobody has it. And then he tries to get with another person. It still doesn't work. And Johnny's getting kind of embarrassed and he's decided he's had enough of that. But you see what happened. He didn't ask the right question. In fact, the right question would have not been an interest, it would have been really tedious to do on television. He would have had to go through the whole audience and get everybody's birthdays to see if there were any matches at all. Okay, so it's funny, the video is cute. The reason why I'm going through it though is that there is actually kind of a serious lesson here for social scientists. It's a lesson about rare coincidences and not so rare coincidences. Patterns that seem so unlikely that you feel like they need an explanation. You feel like they need some alternate theory to explain them because the likelihood that they would happen by chance is so low, versus coincidences that are among a set of patterns that is actually very likely to occur. This is kind of straddling the line between science and pseudoscience, okay? So you think about dreams and what happens the next day in reality. Lots and lots of things happen in your dreams. Lots and lots of things happen in reality. And the probability that like one of the things in the dream matches up with something the next day, the probability that there's some coincidence there is actually not that small. Okay, that some coincidence is going to happen is not that small. The probability that one specific thing that you dreamed about is going to come true, that would be very small, but people conflate the two. So just because you dreamt about a friend and that friend called you the next week, don't get all excited about your prophetic powers there. There's reasonably high probability that something that you dreamed about would cohere with something in reality, and it doesn't make you special. Okay. Or another kind of fanciful example of that was kind of a party game when I was in college, when we had movies on VCR tapes, and you could do this thing with the video of the movie The Wizard of Oz, the one from the 1930s with Judy Garland, and the Pink Floyd album Dark Side of the Moon. So if you start the record album at the third roar of the MGM Lion that starts the movie, it lines up in this really cool way. There's screaming on the record when the house drops on the witch, and the cash register ching ching sound in the song Money lines up with the wizard ripping people off in Kansas. And depending on the refreshments being served, it could just be extremely mind-blowing to do this. And like, not to take the fun out of it, but when you think about all the movies that were made over the many years up to the time when I was in college, and all of the records that were also recorded, the probability that some of them would line up in some ways was not actually all that low. Okay? Nobody said in advance something about what's the probability that there would be a record recorded that would exactly fit the Wizard of Oz. And it does, even the fitness, I don't want to oversell it. It's not that exact. I think I'm remembering the main points where it really coheres. All right, so all the silly stories aside, really the reason why I'm talking about this is a very serious reason for social scientists, because this difference between thinking of a specific coincidence that would indeed be very rare and might beg some kind of different explanation, that it wouldn't really occur by random, so might be taken as evidence for a theory. The difference between that and some patterns going to emerge is the difference between what we call p-hacking and good social science. Okay, so when people talk about p-hacking, what they kind of have in mind is you get yourself a data set that there's all sorts of variables in there, and you just kind of play around with it until you find something that's got a relationship. And then you write it up as if the relationship you found was the idea that you had in the first place. Okay, don't do that. That's not good science. That is cheating. Okay, don't look for some kind of relationship and then write up the paper as though that's what you had in mind all along. Okay, what you want to do is go in with your hypothesis in mind and see if there's evidence for it. That's a much harder thing. Okay, so what the p-hacker does is kind of the opposite of Johnny Carson. Johnny was looking for some kind of not so rare event, but he actually ended up asking about a rarer one. What the p-hacker did was find some relationship in a large data set with lots of variables. It's pretty likely that you can find some relationship, but then talk about it as if that was the specific relationship that they were looking for in the first place. Talking about it as if it was something that was very, very unlikely to have occurred by chance. And that is not scientifically valid evidence for a theory. So the sort of current practices, say in experimental research, of like pre-registering what your hypotheses are before you look at your data, comes from a desire to keep people from this temptation of taking a not so rare coincidence and interpreting it as something much rarer. Okay, so I've got one more thing that I want to say about the birthday problem, but I'll do that in the next video.